Good afternoon, everybody. Welcome back to Borderview Research Farm. We have another virtual field day today. And today we're going to be highlighting some of our interseeding projects as well as some of our forage projects. But what you see out here right now is what we've been calling our wide row corn experiment. But the more technical term for what we're doing here is called solar corridors or solar corridor cropping systems. So what is a solar corridor cropping system? And it's kind of becoming a buzzword. So if you haven't heard it yet, we'll try to define it here. This is based on agricultural principles or just biological principles that if you give crops all the crops the same amount of sunlight, they'll have better performance. And so if you're creating a solar corridor cropping system, you have multiple crops and you're trying to give them each a good amount of sunlight. So think about it this way. For most farmers that grow corn, you may have a 20-acre field of corn. And it's probably true, and you've probably noticed, any of the corn plants that are on the outside, right, not on the inside, so whether it's the outside row or the outside few plants, make bigger ears, sometimes multiple tillers, and maybe taller as well. And part of that is because there's less competition. Likely less competition for nutrients, but also less competition for sunlight. If you walk deep into a cornfield, you know that it starts to get dark when the corn is large, and there's a lot of competition for the sunlight that's coming down. So part of the goal of creating a solar corridor is to provide more plants with more photosynthetic capability, right? So you can see over here, we now have 2 rows of corn 60 inches apart versus the standard 30. So each of these rows are getting more sunlight. And between those rows, we planted another crop. And in this case, it's a cover crop mixture. And you can see that this cover crop is also able to get more sunlight. So we're maximizing both the amount of sunlight the corn can get and the cover crop can get. So as we've been trying to increase cover cropping in corn, we found it difficult to achieve good results from interseeding, and some of that has to do with the amount of light that they get once they're planted. Okay, so we thought if we increase the distance between the corn rows, that the cover crops might grow better. But again, the farmers need the corn. So we want to make sure that we're still getting good corn yields while we're trying to maximize the cover crop growth. And that's what this experiment is all about, is really trying to figure out what's the best way to use this practice of solar corridor cropping systems in the far north with corn silage, with our limited growing season, so that we maximize crop yield and cover crop growth as well. So we did this experiment last year, and so I'll show you the results from that. And one of the things I would like you to first know, as I've already said, is the amount of light that's hitting the ground, this red line, is higher in the wide row corn. Makes sense. You can see right now that there's still light out in the wide row corn. And this is the 30-inch corn, the blue line. So there's always less light in the 30-inch, between the 30-inch rows, and there's always more light between the 60-inch rows, until actually right about now. The canopy will begin to close for both types of crops, okay? But you can see there's more light for the corn to grow and for the cover crops up until about mid-August. And then they're about the same until we get closer to harvest, okay? So more light. The other thing that we see is more cover crop growth, and that's something that we're after. So here's the results from last year. The 60-inch row corn had almost 2,000 pounds of cover crop dry matter, biomass, when we harvested the corn last year. Okay? And you can see when we harvested the 30-inch row corn, we only had about 500 or 600 pounds of cover crop dry matter biomass. So obviously this was a much better growing scenario for the cover crop. What about the corn? What happened with the corn yields? Okay, the red line here shows you the corn yields. When we grew corn in 60-inch rows, we yielded roughly about 20 tons of corn silage per acre, okay, in the 60-inch rows. When we grew the corn in 30-inch rows, we yielded 22 to 23 tons of corn silage per acre. Okay, so basically there was a 2 to 3 ton yield decline when we grew corn in the 60-inch rows. But what I want you to look at next is the population. The corn population was 30 or 34,000 plants per acre in the 30-inch rows, but only 25,000 in the 60-inch rows. So we really have less corn growing per acre in those 60-inch rows. If we had the same amount growing in the 60-inch rows, would the yields have been the same? That's the question, and that's what we're evaluating now, is if we make all things equal, the corn population, variety, fertility, will we be able to match these 30-inch row yields? And if we can, we feel like this is a system that could really yield major benefits, both crop-wise and conservation-wise. What we're going to do now is look at the same cover crop in the 30-inch rows. So again, this is a mixture of sun hemp and sunflowers. There's some cowpeas and buckwheat in here. These are all summer cover crops. You can see they're doing very well, especially now that we've had some rain. And then if we go to that same mixture in 30-inch rows, let's walk over here. You can see there's still growth, not too bad, but not nearly as much as the 60-inch rows. The other thing you can see is that it's much darker in here, right? There's a lot less sunlight. So the cover crop's not getting as much water, fertility, and then also light to grow.